Okay, so like I said, we are starting completing the square method, which is still under quadratic equations. And then we'll also look at the types of roots of quadratic equations. All right, so let's quickly begin. All right, so the completing the square method is also one of the simplest methods that you can use to solve a quadratic equation. So it is this same method that is even used to derive what is called the quadratic formula. The formula that we were using last time, this formula, which is just x is equal to negative b plus or minus the root of b squared minus 4ac, and then everything divided by 2a. So this is the formula that we call the quadratic formula. So it is this same, it is this same method that is used to derive this formula here. All right, so let us see how we do the derivation, because for your lecturer to put it in the handout, it means that it's important. He might ask you to derive it. So let us derive this formula. Okay. So the same way I'm going to derive the formula is the same way that you solve quadratic equations using this method. Okay. Right. So we have this is a format of a quadratic equation. This is what we discussed the time I was just introducing quadratic equations. So this is the format for quadratic equations, and this is the one that we're going to take to this format here. So it's the one that we're going to use to derive. We use the completing of the square method to get to this formula. So let us quickly begin. So the first thing that you need to do when you want to derive that formula, or when you're completing the square of any quadratic equation, is you first divide the whole function by a. In other words, you make the first term there with x squared, you make it at least just remain a variable without a constant, rather without a coefficient. So how do you do that? You can just divide everything by a. So we have c, then is equal to 0. So we divide everything by a. So the first part there will just remain as x squared. Then the second part there will just remain b over a, x. And then the third part there will remain c over a. And then we have a 0 this side. So from there, we take c over a to the other side of the equal sign. So meaning we're going to remain with x squared this side plus b over a, x is equal to negative c over a. And then from there, we find half of b over a. So half of b over a, when you say half of 2, when I say half of 2, it's just the same as multiplying 1 over 2 times 2, which gives me 1. When I say half of 4, it's just the same as multiplying 1 over 2 times 4, which gives me 2. So when I say half of b over a, it's just the same as multiplying b over a times half. So half times b over a, which is just going to give me, b. This will give me. Let me just write it properly. Yeah. So this will simply give me b over 2a. Yeah. So this is what I'm going to get. So this is what I'll write there. So I'm going to say x squared and then plus. Then this part here, I'm going to write half of b over a. That is simply just b over 2a. So I'm going to put it this side and then I'll square it. And then I have this b over ax. I'll write it there, b over ax. Then this is equal to, so remember that remember the time we started looking at equalities of equations. So whatever you do on this other side of the equation, you'd also do it on the other side. Remember, there was a part which was like this: A is equal to B. So I said, if you add C this side, you also have to add C this side. So since we have added B over 2A squared on this side, it means that this other side will also be added by B over 2A, then squared. So now we can simplify this. So we complete the square of the first two terms, meaning we're going to say this will be x plus b over 2a, and then we put them in brackets and then say squared. Then we forget about this, we omit this one. Then we say equals, we equate this to that. So we're going to have negative c over a, then plus we have b, we open the brackets there, we're going to have b squared over 4a squared. This is what we're going to have. Okay. Yeah, so someone is saying network is bad. Maybe it's just in your area. So we're going to send this recorded session and then you have time to watch it at your own time. Okay, so from there, let us now finish up this. So what we do is we can now square both sides. Yeah, or if you want, let us first express this other part as a single fraction. So how do we do that? So we have this side, we have x plus b over 2a, and then everything squared. So this other side, we're going to have, when you express this as a single fraction, we find the common denominator. The common denominator will be 4a squared. So we say, let me start with a positive one. So it's a 4a squared into 4a squared. The answer is simply just 1. 1 times b squared, this will be b squared. Or let me just start with the same one in order for me not to confuse some people. So a into 4a squared, this will be 4a. 4a times negative c, we're going to have negative 4ac. Then 4a squared into 4a squared, this is just 1. And then 1 times b squared, this will just be b squared. Yeah, so this is what we're going to have. And then let me proceed on this other part. So we can rearrange this on top. So when we do the rearrangement there, we're going to have, first let me write what is on the left there, which is x plus b over 2a squared is equal to, so when I rearrange that, I can start with b squared minus 4ac, then everything divided by 4a squared. So I'm going to square root both sides. So I'll square root both sides, and of course this square root symbol, it always moves with a plus or minus. Yeah, so I shouldn't forget to add the plus or minus. So when I square root both sides, on this other side, this square root and the 2 there will cancel. So I'll just remain with x plus b over 2a, then is equal to plus or minus the square root of b squared minus 4ac, then everything divided by, so the square root of 4a squared will simply just be, the square root of 4a squared will simply just be 2a. So I'll write my 2a there. And then I'm going to have x this side, and then I'll take this part, which is b over 2a, to the other side of the equal sign. So when I take it to the other side of the equal sign, I'm going to have negative b over 2a. Then there's this plus or minus there. Then we have the root of b squared minus 4ac, then everything divided by 2a. So from there, remember, according to the rules of mathematics, if you're adding or subtracting two numbers which are having the same denominator, you can just add or subtract the numerators. So we just combine the numerators there. So in the numerator, we have negative b plus or minus the square root of b squared minus 4ac. Then everything divided by the common denominator there is simply just 2a. So this is what we call the quadratic formula. This is the quadratic formula. This is the one that I just wrote on top here, the one that you can see on the screen. This one. Yeah, so that's the quadratic formula. That is how you derive it. All right, so let us look at some examples. So this same process that I've gone through here is the one that you use to solve quadratic equations using the completing of the square method. So this is the one that you always have to use. All right, so let us quickly move on to the next question, which is an example. So this example says solve by completing the square. So the first thing we said, we divide by the coefficient of x squared. So this side, the coefficient of x squared is simply just 1. So when you divide this equation by 1, it will still remain the same equation, which is x squared plus 4x plus 2 is equal to 0. The next step, you take these two to the other side of the equal sign. So meaning you're going to have x squared plus 4x this side. Then when you take this to the other side of the equal sign, you're going to have -2. And then from there, what you do, from there, what you simply now do is you divide, rather you find half of 4x. So when you okay, so you find half of 4. So half of 4 is simply just 2. So half of 4, so I have x squared, then I say plus, half of 4 will simply just be 2. So these 2, I'll write it there, and then I'll square it, then I'll write my 4x there. But remember, the same 2 squared that I've added this side, I'm also supposed to add it on the other side of the equal sign. So I'll add positive 2 squared on the other side of the equal sign. So from there, what I'm going to do is to complete the square of these two first terms. So what I'll do is I'll just write x, and then I'll take the sign of what is in the brackets. So if we had -2 in the brackets there, I would have written -2 there. But since there is a +2, so I'm going to write +2, and then I'm going to say squared. Then I'll equate this, I'll omit this, I'll forget about this, and then I'll equate this to what is this side. So I have -2 on the other side, and then we have 2 to the power 2. The answer will simply just be 4. So I'm going to have x plus 2, and then squared is equal to, then -2 plus 4 there, this will simply just give me 2. Then from there, what I can do now is to find the square root of both sides. So I have x plus 2 there, squared is equal to 2. So when I square root this side, I'm also going to square root this side. Of course, this side, when I'm square rooting, I have to include plus or minus. All right, so what I'm going to do next is, so this square root and that square will go. I'm going to remain with x plus 2 this side, and then this other side, I'll still be having plus or minus the root of 2. So I'll take these 2 to the other side of the equal sign, meaning I'm going to have x is equal to -2 plus or minus the root of 2. So from there, I can now conclude to say the final answer for this equation is simply just x is equal to -2 plus the root of 2, and x is equal to -2 minus the root of 2. So these are the two solutions for this quadratic equation. Okay, so let's take a look at another example.
No, sir, before you go, I didn't hear anything. Kindly please repeat what you are saying.
Where exactly?
Especially the first part, from x squared plus 4x plus 2. Just start from there.
Yeah, so I said you just find half of this. First of all, you take these 2 to the other side of the equal sign, and then you find half of 4. Half of 4 is 2. This is the 2 that I've written here. But make sure that that answer that you get, you square it. And then the same thing that you've added this side, you also add it on the right-hand side of the equation. Then from there, you simplify the expression by completing the square of this and that, meaning you are just going to write this x plus what you have there, and then you square everything. You put the squared outside there. And then from there, you simplify this side, 2 to the power 2, the answer is 4. Then negative 2 plus 4, you get this answer 2. So on this other side, you still have this. And then from there, you find the square root of both sides. When you find the square root of both sides, you get to this. And then when you get to that, you just take this 2 to the other side of the equal sign. Then when you take it that side, you have this. Then you write your answers like that. Okay, let me solve the next one. Just pay particular attention on the next equation that we're going to solve, because it's just the same, except that it will have a 2 in front of x squared. So remember what I said. Okay, just pay particular attention on this one. The procedure is just the same. So I'll take time to explain this one. Remember what I said, if you have if x squared has a coefficient, the first thing that you do is you divide everything by a. So the value of a in this expression, we have a squared, ax squared. This is the general formula for the quadratic equation. So what you do is you divide everything by a. So in the first example that we had, we never had a. The value of a actually was just 1, because the coefficient of x squared here is simply just 1. Now, in this case, we have the value of a, which is 2. So we divide everything, the whole equation, we divide it by 2. So we have the equation, which is 2x squared plus 3x minus 6 is equal to 0. So we're going to divide everything by 2, everything by 2, everything by 2, everything there, 2. So we're going to remain with the equation, which is just equal to x squared plus 3x over 2, then minus 6 divided by 2, the answer is 3, is equal to 0. So you take this negative 3 to the other side of the equal sign. So we're going to remain with x squared plus 3 over 2x, then this will be equal to positive 3. So we find half of 3 over 2. So remember what I said, I gave some examples to say, if you've been told to find the half of 20, it's just the same as multiplying half times 20, which will give you 10. If you've been told to find the half of 50, half of 50 is just the same as half times 50. So in the same in this expression, we are supposed to find the half of 3 over 2. So half of 3 over 2 is just the same as multiplying half times 3 over 2, which will give us 3 over 4. So I'm going to write x squared, and then I'm going to say plus. The half of 3 over 2 is simply just 3 over 4. So I'm going to square this, and then I'm going to write my 3 over 2x here. And then this will be equated to 3, this 3 there. And then, of course, since this is an equation, whatever that we add on the left-hand side, we have added this part. We also have to add it on the right-hand side, this side, according to the rules that we learned when we just started looking at equalities. So we also added this side. So we complete the square of these two parts there. So how do we do that? We just write whatever that is there. We have x there, then we have positive 3 over 2. So we have positive 3 over 2 there. And then this is squared. Then we forget about this. We don't have to go on with this one, because when you expand this, you're going to have this somewhere. So when you expand this, this is going to cancel with that, because there's also this part which is on the other side, this side, right? So we can just say we forget about this, and then we write this equal sign there. Then we have 3 plus 3 to the power 2, the answer is 9. 4 to the power 2, the answer is 16. And then we can simplify this expression. We can say x plus 3 over 2, then squared there. This is equal to, and then when you add 3 and 9 over 16, you are going to get, this is 3 times 16, that is 48 plus 9. 48 plus 9, that should be 57. So you get something like 57 over 16. So I was just using a shortcut of finding fractions. So don't get confused by what I was saying. So you can just use the normal way you find fractions, where you say over 1 and then find the common denominator, then add everything like that. Okay, so this is what we have. So the next thing that we're supposed to do is we find, yeah, so we can take this to the other side of the equal sign, or rather we can square root the both sides. So when you square root both sides, sorry, there was a mistake here. This is supposed to be 3/4 and not 3/2. 3/4 and 3/4 there. Okay, so we take this to the other side. Well, I mean, we square root both sides first before we take in 3/4 to the other side. So if we square root both sides, so we have x plus 3/4. And then we have this is squared is equal to 57/16. So we square root this side, we also square root on the other side. So when you square root this side, the answer that we're going to get is simply just this square and that square root to cancel, meaning we just have x plus 3/4. And then we have this is equal to plus or minus the root of 57. And of course, the square root of 16 is simply just 4. So we're going to have x is equal to, when you take this 3/4 to the other side of the equal sign, we're going to have negative 3/4. Then we have plus or minus root 57/4. Since the denominator is the same there, we can combine them and say x is equal to negative 3 plus or minus the root of 57, then everything divided by 4. So this is the solution. Or if you want, you can split them by saying the value of x is equal to negative 3 plus negative 3 plus root 57, everything divided by 4. Then you say, or x is equal to negative 3 minus the root of 57, everything divided by 4. So this is how you use the completing of the square method. So before we can proceed, if you have any questions, please feel free to ask.
So another example.
Another example?
Excuse me, sir.
Okay.
Yes. I didn't understand where here on x is equal to negative 3/4 plus or minus square root 57/4. Where did you take the other, this 4?
You find the common denominator.
Okay,
Yeah.
thank you.
Okay,
Right.
thank you very much. The one was said another example. Let me find an example which has a minus here. All the examples that we've done have a plus there. So let me check if there is, okay. Let me just erase one of these parts.
As you are checking for, I just wanted to find out on the equation itself, the way it comes. Is it a mass that the last number, in this case, where you have 2x squared plus 3x minus 6, is it a mass that you have to ignore the last number? Like the C in this case?
This one, 6.
Yes.
I've not ignored it. I took it, I actually divided it by 2 and then took it to the other side of the equal sign.
Okay.
Yes. So after dividing it by 2, it gave me 3. And then this 3, I took it to the other side of the equal sign. It became positive 3, this negative 3. So I've not ignored it. The part that I said you have to ignore is this one.
Oh yeah, that's the one I meant.
Yes, this is here when you're using completing the square method, you always have to ignore this one. Unless you want me to show you how and the reason why we ignore it. If it will not take us time, I can show you right now. But anyway, let's just, I'm going to make a tutorial where I'm going to just be solving questions on the completing of the square method. That's where I'll explain where that part goes. For now, let's just focus on solving questions. Yes. All right, so let me erase one part so that we quickly solve another question. I erase this same part here. So let me just make a question just right here. So I want my answers to be x is equal to -3 and okay. Okay, let me do this. Then x is equal to -5. So let me just make a question quickly. We have x minus 3, then we have x plus 5. So this will be x squared -3. Okay, let me change the signs. So I'll put this one positive and then this one negative. This one and this one negative. Rather, this one positive and then that one negative. Okay, so I'm going to have x plus 3, then I'm going to have x minus 5. So this will be x squared positive 3x negative 5x, and then we have -15 is equal to 0. So this will be x squared, then this will be -2x, then -15. Okay, so the question will be x squared -2x, then -15 is equal to 0. Okay, so forget about this question. All right, so if this is the question, so we first have to divide everything, the whole equation, by the value of a. So the value of a in this case is simply just 1. So when you divide this equation by 1, divide by 1, divide by 1, divide by 1, it will still remain the same equation, which will be x squared minus 2x minus 15 is equal to 0. Yeah, so the next step is for us to take 15 to the other side of the equal sign. This -15 will cross the equal sign. So meaning we're going to have x squared minus 2x. So this will be positive 15. And then once we have this, we are going to find half of -2. So half of -2 is just the same as multiplying half times -2, which is just -1. So we're going to have x squared, and then we say plus, and then this -2, half of -2 is simply just -1. And then we square this, then we say minus 2x is equal to, then we have 15. Whatever we added this side, we also have to add it on the other side. Yeah, so we can now write this. We can complete the square of these two parts, meaning we're going to have x. I said you always take the sign that is inside there. So in this case, on the previous two questions that we had, the sign was always positive there. So in this case, we have a negative inside. So I'm going to write -1 there. And then you say squared is equal to, you forget about this, you just write this equal sign there, is equal to, so we have 15, and then a -1 squared, this will simply just give us +1. So this will now be equal to x plus, rather x minus 1 squared is equal to 15 plus 1, this is 16. So we can now find the square root of the square root. I mean, we can now square both sides. So squaring both sides, we're going to have x minus 1 squared is equal to 16. So the square root of this side, we also find the square root of this side. So we're going to have this part, this square root, and that 2, which is the square, will cancel. So just remain with x minus 1 is equal to the square root of 16. This side was supposed to have plus or minus. The square root of 16, this will be plus or minus 4. So we can now take this -1 to the other side of the equal sign. So we are going to have x is equal to 1 plus or minus 4. So the value of x will simply just be equal to 1 plus 4, and the other x will be equal to 1 minus 4. So the first value of x will be equal to 1 plus 4, which is just 5, and then the other x will be 1 minus 4, which is just equal to -3. Yeah, so this is how we find the answers. These are the answers that I first started with when making this equation. Yeah, so this is how simple completing the square method is. It's very simple and straightforward. Okay. All right, so let us quickly move on to the next topic. Oh, sorry, the next part of quadratic equations. Okay. So we have the roots. I even forgot to put the title. So we have roots, types of roots of quadratic equations. So we have the types of roots. So before I start solving any question about the types of roots, let me first introduce certain curves to you. You have to master certain things. You have to know them actually. So these things I'm talking about, the first thing is that when you look at the quadratic equation, the quadratic formula, we said its x is equal to -b plus or minus the square root of b squared minus 4ac, then everything divided by 2a. So what is inside here is called the discriminant. So this one, some books, they call it the determinant, though it's a few books write it as the determinant, but it's normally called the discriminant. So this can also be written as -b plus or minus the square root of d, which is the discriminant, everything divided by 2a. So from there, what I just wanted us to get from this is d, which is the discriminant. So d is simply just given by, let me just write it here. D will be equal to b squared minus 4ac, the thing that is just under the root there. So now you have to understand one thing. When d is negative, it means that when d is negative, meaning when d is less than 0, when d is less than 0, this also means that d is negative. So when d is less than 0, it means that the square root of a negative number, when d is negative, the square root of a negative number here will give us a complex number. So what that means is that the answers that you are going to get, yeah, by the way, the answers that you always get after solving a quadratic equation are called roots of a quadratic equation. So if at all d is less than 0, it means that at one point you are going to have the square root of a negative number. So the square root of a negative number is a complex number. It's an imaginary number. So that implies that the answers that you get when d is less than 0, there will be imaginary numbers, which will just be complex roots, or you can say imaginary roots. So when d is less than 0, it means that the value of b squared minus 4ac is less than 0. So the answers that you're going to get will be imaginary numbers. So you get complex roots. That's what it means. And then if d, let me also be doing some sketches. So when d is less than 0, it means that when you draw the x or y plane, or when you draw the curve of that quadratic equation, that curve will not touch the x-axis at any point. So it will either be up on top of the x-axis or down, or it can be this side or there, or it can be there or there, but it will not touch this line here, the x-axis. That's what it means. And then when d is greater than 0, it means that that given quadratic equation has two different real roots. So it has two different real roots. Some books, they say two different or two unequal roots, meaning the roots are not equal, they are different. So after solving that quadratic equation, you're going to find two different answers, which implies that b squared minus 4ac is greater than 0. So meaning you're going to have two different answers. The first answer will be x is equal to a, and then the second answer, let me use alpha, x will be equal to alpha, and then the second answer will be x is equal to beta. So this implies that when you draw the x or y plane, the curve will meet the x-axis at two different points. So it can be, if it's like this, it means that the first value of x may be there, and then the second value of x may be there, which is beta. So it will meet the x-axis at two different points. That's what it means when you say it has two complex roots, or sorry, it has two real roots, not complex roots. It has two real roots. That's what it means. And then when we talk about d being equal to 0, when you find that the discriminant is equal to 0, this implies that the given expression has two equal roots, meaning the curve after sketching will only meet the x-axis at one point. That's what it means. So when the equation has two equal roots, it means that the discriminant, which is just b squared minus 4ac, this one is going to be equal to 0. Yeah, so the link will soon end. I'm going to send another link. So when this is equal to 0, it implies that this implies that you have two equal roots, meaning the first value of x can be alpha, meaning and the second value of x will also be alpha. I'm sure you've encountered such equations. When you solve the quadratic equation, you find that maybe the value of x is 2, and then the other value of x has also given you 2. So this means that the quadratic equation has two equal roots. And when you draw the curve of that quadratic equation, it will only meet the x-axis at one point, to just touch the x-axis at one point like that. This is what it means. So I'll send another link so that we do some examples down here.